Now we are going to discuss some problems for divisibility. First question is, which of the following is divisible by 45? Options we are having, and we have to note that a number is divisible by 45 if it is divisible by 5 and 9. We know that 5 into 9, 5 nines are 45, right? So, a number is divisible by 45 if it is divisible by 5 and 9. Okay, this way you have to find. So, if you get a number over here, divisible by, you get a number, you have to find how you get that. Okay, that is if it is divisible by 5 and 9. That is because 5 nines are 45. Same way. Okay. So if it is divisible by 5 and 9, then we can say that the number is divisible by 45. Okay. Now, we know how to find whether a number is divisible by 5. The unit portion, digit at the unit section, unit portion should be 0 or 5. So all the numbers are divisible by 5. Then we have to check whether the number is divisible by 9 or not. So for that, what we have to do is, we have to find the sum of the digits of the numbers. Okay, that is 6 plus 2 plus 2 plus 8 plus 0. And you will get there 24. And 24 is not divisible by 9. So, this is not the answer. Next is 5 plus 7 plus 3 plus 9 plus 2 plus 0. And it is 26. Same case, 26 is not divisible by 9. Okay. Or you can take 6 plus 2, 8 also you can take. That way also you can take. 8 is not divisible by 9. And the next is 7 plus 2 plus 4 plus 2 plus 7 plus 5. And the answer is 27. 27 is divisible by 9. Or as above, we can take 7 plus 2, 9. So 9 is divisible by 9, right? So this is okay. So before concluding, just go to this option also. 8 plus 4 plus 5 plus 1 plus 8 plus 5. And it is 31, which is not divisible by 9, right? So the answer is option C. Okay. Now, second question. Find the value of k so that k 1, 2, 3 be divisible by 11. The value of k you have to find. So, a number is divisible by 11. Divisibility rule of 11. Please note it down. That is, a number is divisible by 11 when the difference between the sum of the digits in the odd and even places is 0 or a multiple of 11. Okay, I will show over here. The number is k 123. Find the value of k so that it is divisible by 11. Okay, so we have to check whether it is divisible by 11 or not, and we have to find the value of k. So divisibility by 11, the rule given is the sum of the odd portions or odd digits, that is k plus 2. Okay, k is at the first position and 2 is at the third position. So k plus 2 minus even position values, that is 1 and 3. Okay, 1 plus 3. K plus 2 minus 1 plus 3 is equal to 0 or any multiple of 11. And here you can find the value of k. Right, k plus 2 minus 1 plus 3 is equal to 0. So you can, while solving, you will get k is equal to 2. Okay. Third question. For what value of x and y the numbers 7x 357y be divisible by 72? Okay, this is the value, this is a number, and x and y we have to find. So divisible by 72. In the previous question we have seen 72. 8 nines are 72. Okay, so these are the values, and then for divisibility by 8, we know how to the rule of divisibility by 8 we know, right? So the 3, that is unit tens and hundreds are considered, and we have to check whether it is divisible by 8 or not, right? So if the value of y is 6, it is divisible. And for 9 we know sum of the digits should be divisible by 9. So that way you will get 8. So the y value is 6 and x value is 8. Okay. Fourth question, when a certain number was divided by 195, the remainder was 57. When the same number is divided by 15, what is the new remainder? That is the answer. You have to find. Okay. The new remainder you have to find. Here the shortcut is given. The new remainder is obtained after dividing the older remainder by the new divisor. I repeat the question. When a certain number was divided by 195, remainder was 57. What will be the new remainder when the same number is divided by 15? Okay. So the new remainder is obtained by dividing the older remainder by the new divisor. So here the older remainder is 57 and the divisor is, new divisor is 15. So 57 by 15, the answer is 12. Okay. Next question, two numbers are divided by certain divisor. They leave the remainders 157 and 165 respectively. When their sum is divided by the same divisor, the remainder is 145. Calculate the divisor. That's a question. Okay. Two numbers are divided by a certain divisor. They leave the remainder 157 and 165 respectively. When their sum is divided by the same divisor, the remainder is 145. Calculate the divisor. See here again, shortcut is given. If two numbers are divided by a certain divisor and the remainders are R1 and R2, and when their sum is divided by the same divisor, the remainder is R3, then the divisor is R1 plus R2 minus R3. Okay, if two numbers are divided by certain divisor and the remainders are R1 and R2, and when their sum is divided by the same divisor, the remainder is R3, then the divisor is R1 plus R2 minus R3. Just substitute. Okay, too simple to find the answer. 157 plus 165 minus 145. Okay, and the answer is 177. Now, sixth question. A number is divided by a fixed divisor. The remainder is 47, and when twice of the number is divided by the same divisor, the remainder is 45. Twice of the number. Okay. Divided by the same divisor, the remainder is 45. Here also, R1 is equal to 47, R2, again you have to take 47, and R3 is 45 given in the question. Okay, so 47 plus 47 minus 45, and that is 49. Same formula, R1 plus R2 minus R3. But here only one remainder is given, and the second remainder, the same one you are repeating. Okay. Here's a question for you. The number when divided by a divisor leaves a remainder 65. When twice the number is divided by the same divisor, the remainder is 57. See, the same one which we have done just before. Okay, sixth question. So 65 plus 65 minus 57, that is 73. See the question number 8. If a whole number n is divided by 4, we will get 3 as remainder. What will be the remainder if 2n, see, twice is divided by 4? Okay. In the previous question, we found the divisor, but here we have to find the remainder. Same way, 2n. Okay. So twice. So there we know that remainder was repeating. R1 plus R2 minus R3. Right. So R1 and R2 were same. Same way here, R1 is 3 plus R2 is again 3 and R3 you have to find. Okay, remainder you have to find. So R3 I am giving as X. That way you find the divisor. Here the divisor is given as 4. So 6 minus X is equal to 4. So X is equal to 2. Okay, so you got the answer. Next question. What should be added to 13,533 to make it exactly divisible by 31? So 13,533 is not exactly divisible by 31. So we have to add a certain value with 13,533 to make it exactly divisible by 31. So what should be added? What is that number? Shortcut is given. Number can be made divisible by the given number either by adding divisor minus remainder with the number or by subtracting remainder from the number. These are the two ways. Okay, either by adding divisor minus remainder or by subtracting remainder from the number. So the given number is 13,533 divided by 31. Okay. Just divide. We know how to divide. Okay. Just the way how you divide. Divide. You find the remainder as 17. So here options are given. Subtracting remainder from the number or by adding divisor minus remainder. Here divisor is 31 and the remainder is 17. So the value difference is 14, that is to be added with a number to make it exactly divisible by 31. Okay, that is the question. What should be added? So 14 is to be added to make it exactly divisible by 31. Okay. Now the last question, find the nearest number to be added to 32,373, which is exactly divisible by 35. Same question, same method. So 32,373 divided by 35, the remainder is 33. Okay. Here, find the nearest number to be added. So now the shortcut given over here. Now the exactly divisible number can be calculated either by subtracting 33 from 32,373 or by adding 2 divisor minus remainder with the number. Okay, here 2 has been added and you are getting the nearest number as 32,375, which is exactly divisible by or completely divisible by 35. Okay, so these are some of the commonly asked questions related to divisibility. So just go through this, and the same pattern questions are normally being asked. You can answer them. Okay. So hope it was clear for you. Thank you.